So I know I taught you guys about radicals, but we're going to go into it a little bit more today because we're going to go into some college algebra stuff. So let's start out with a little, like, you know, kind of a refresher. So if we're given, like, you know, square root of 36, we know that equals 6. But what you don't know is there are actually two answers to that. Because they want, it's actually 6 and negative 6. Because 6 times 6 is 36, and negative 6 times negative 6 is also 36. So now we're dealing with two answers. Because I taught you originally that there were not. There's just the one. But technically there's always two answers when you have something like this. So if we're given, but here's the difference here. So if we're given something like this, this is meaning they only want the negative one. So the square root of 81 is 9, but they only want the negative 9. They don't want the positive one because it's negative 9. So what if we're given something, though, that looks like this? If the negative is inside, I taught you guys that it's no solution. And it is. So it does not exist. If the negative is on the inside, it's not an actual, you can't take the square root of that. That's just, there is a way to, but I haven't taught you that yet. I think we get to that, do we get to that in this chapter? We don't, we get to that in the next chapter. There is a way to take the square root of this, but I'm going to teach it to you next chapter. And it's exciting, guys. So exciting. So now I'm going to give you some radical expressions, and we have to simplify them. Well, if I'm given the square root of 4 to the 10th, you look at that and you're like, what the heck is that? Well, what we're actually doing is we are taking, we're just going to take half of the exponent, and it'll take it out of the radical. So when we do that, it's actually 4 to the 5th. You just cut this in half. So your answer is 4 to the 5th, then you take it and it's a big number. Usually they don't make you do anything over 5. So the answer to this is 1024. So we're taking the square root, but basically what we're doing is we're cutting that, my brain just broke, we're cutting the exponent in half. So if we're given the square root of 13 to the 8th, the base stays the same when we take it out, and then just cut this in half. 4. So if we're given 23, this stays the same, and then you bring that out and cut it in half first. So, I have no idea what my child is watching. So, if we're given something like this, a to the 8th. Hang on, someone texted. Oh, Lord. My Lord. Oh, okay, you're going to have to give me time. Cut this in half. The base stays the same. And it goes down to 4. This is our basics of this. Give me like 2 seconds. And sorry guys. Oh my gosh, I can't even spell. I know, sorry for this. Okay. Whoop. Oh, I dropped all my markers. Okay. So if we're given something like this, where we have m 14th, base stays the same, and you cut the exponent in half. That's it. So this is simplifying radical expressions. So I did teach you guys also multiplying radicals together. What is he watching? I have no idea. So, if we're given this 16a to the 6th, well, we know that a is going to stay the same, but we cut the exponent in half. Now, what's the square root of 16? 4. And we simplified that. I think he's watching zombie stuff in there. I don't. So, if I'm given 49 b squared c to the 16th. Well, I take the square roots as I go. Square root of 49 is 7. B squared cut in half is b. And 16 cut in half is 8. And I simplified that. So this is simplifying with actual variables in there. The variables with an exponent, just cut the exponents in half. That's all you're doing. I know, sounds confusing, but it's really not. So I know I taught you guys, factoring last time, or like when I taught you guys radicals, I taught you how to do, getting them into their prime numbers. But what if we're given something like this? No. I have no idea what he's watching. So what if we're given something like a to the 5th? That doesn't split in half very nicely, right? Well, what we can do is we know we're going to split this. We know we can split an a to the 4th in half, and we're left with an a, right? Because that's a perfect square. Well, it's an even number. Even numbers. What? So I know I can take the square root of that, and I actually get a squared, and what's left underneath our radical is an a. That's how we simplify something that's an odd number, split it into its even, cut it in half, and what's ever left over stays underneath the radical. Okay? So if we're given a big one, like, oh my gosh, m to the 11th, n to the 3rd, well, the even number of m to the 11th is n to the 10th, and then we're left with an m. The even number of n to the 3rd is n squared, left with an n. Well, cut m to the 10th in half, we get m to the 5th. Cut n squared in half, you get n. And underneath our radical, we have an n and an n. Simplified. Pretty cool. My kid watches the weirdest stuff. So, if we're given something like this, though, $50 n n n squared t. Well, into the 9th. Sorry, that's a 9. Okay, so let's split the m. We have n to the 8th, n, n. Split the n. Well, we don't even have to split the n, sorry. Ha! Don't even have to split the n. But we do have to split the 50. And 50 can be split into 2 and 25, because there's a prime number. So we're taking the square root of 25, which is 5. N to the 8th cut in half is n to the 4th. N squared cut in half is n. And what we're left with underneath our radical is a 2, an n, and a t. 2, n, t. And we've simplified that. Cool? Okay, looking at this one, you're like, oh crap, what do I do? I'm given the square root of x minus 2 squared, all we have to do, we're going to cut that in half, pull it out, x minus 2, right? And we know how to add like radicals. I taught you guys that in my other radical video. So what if we just add variables into it though? So if we have 18b minus 50b plus 12b. Well, none of these bases are matching yet. Like, yeah, they have b's in them, but we have to figure out how to match the bases before we can even add or subtract. So, what I'm going to do is I'm going to take the prime numbers of these guys. So 18 can be split into 2 and 9. Yes, and 50 can be split into 2 and 25. 12 can be split into 3 and 4. Well, where are my prime numbers? One here, one here, one here. So this now cuts down to 3 square roots of 2b minus 5 square roots of 2b. And this cuts down to plus 2 square roots of 3b. Well, we're going to combine some of our like terms. What are our like terms? Like terms have the same number underneath the radical. So this one is not going to go anywhere. It is its own separate entity because it's a 3b, not a 2b. So now we're just going to do what's 3 minus 5. 3 minus 5, negative 2 square roots of 2b. And that is this one simplified. You have to simplify the radicals before you can add or subtract them. That's what you have to do with adding and subtracting. Simplify the radicals, see if you can get bases to match. So now what if we're multiplying radical expressions? Right? So what we're going to do here, we're given 5 square roots of 11 multiplied by 7 square roots of 5. What we do is we multiply the coefficients, and the coefficients are the numbers in front of the radicals. So we're going to multiply coefficients, and we get 35, and then multiply what's underneath the radical, and you get 55. Well, 55 is prime, can't go down, so this is that multiplied together. You can't do anything else with it. This is how we're going to be multiplying them. I have no idea what's happening in the room next to me. So what if we're given 4 square roots of 2y times 3y square roots of 6y. Wow, they're all slanty that way. Multiply your coefficients. 4 times 3 is 12, and we're going to take the y with it. 2 times 6 is 12, and then we have a y squared, because y times y is y squared. But we can simplify what's underneath this radical by doing a 3 and a 4, and then we're going to cut this y in half. So we know our perfect square is a 4. So when we take this out, we're going to do 2 times 12, which is 24, and then y times y is y squared. And we're left with 3. So you just make sure when you're multiplying, just make sure when you get to what's left underneath the radical, take out what you can, move it outside the radical so you can take the square root of things. But what if we are looking at something like this? Square root of 3, 6 square roots of 5, minus 2 square roots of 6. So let's look through this guy. We are going to just distribute in the square root of 3. And we distribute it to the square roots because you can't multiply this So what we're going to do is we're going to do 6 square roots of 15 minus 2 square roots of 18. Well, 15 I can't simplify because it's a prime number. But we can simplify the 18 by doing a 2 and a 9. And then the square root of 9 is 3. So 3 times 2 is 6. So I get 6 square roots of 15 minus 6 square roots of what's ever left is our 2. We can't go any further because nothing here combines. Okay? Well, going along the same thing here, we're just making it a little more complicated. It's not complicated, we're just adding a little more to it as we move on. So let's move on to something where we have 2 square roots of y, square root of 5y, minus 6 square roots of 3. Close my parentheses, sorry. So we take the 2 to where the coefficients are and take the y to where the radicals are. So 2 times 1 is 2. Y times 5y is 5y squared. Minus 2 times negative 6 is 12. Y times 3 is 3y. So now we can take something out of this guy right here because that is an even number. So when we do that, we get 2y square roots of 5 minus 12 square roots of 3y. And we can't go any further with it, so we just stop. Okay? So now let's add another step onto it. And I know I taught you guys this, I don't remember what lesson I taught you guys this, but I know I taught you guys something like this, where if I'm given square root of y plus 4 and the square root of y minus 6. So I know I taught you guys this method because I like to keep track of things by drawing a box. Okay, so now I have my box and it has to be a 2 by 2 because I have the square root of y plus 4 square root of y minus 6. Now we just multiply as we go. Well, y times y squared. Y times, or square root of y times 4 is 4 square roots of y. Negative 6 times the square root of y is negative 6 square roots of y. And then negative 6 times 4, negative 24. Well, now let's combine our like terms. Well, these are our like terms here. And 4 minus 6, negative 2y, or square roots of y, sorry. Negative 2 square roots of y minus 24. But look here, and we're given y squared, which means we just cut that in half and pull it out. So it's y minus 2 square roots of y minus 24. That made us keep track of everything a lot easier. I like the boxes because then I'm like, oh, I'm not losing my marbles. So let's do another one with a box. I hope I'm not moving too fast. So if we're given 5 square roots of 3 plus the square root of 7 times the square root of 3 minus the square root of 7. Okay, so let's draw our box. And it has to be a 2 by 2. Do you know you guys can make this as big as you want? I used to do this in college when I got bored in my classes. I would just make up random equations and then just do the box method just to solve them. I had one that filled up an entire page of my notebook because I was just bored in ethics and values. Boring class. Hate that. So we have 5 square roots of 3 plus the square root of 7. Oh, that's a 3, guys. 7. And then the square root of 3 times negative square root of 7. All right, so now let's start multiplying. Well, we're going to be left with a 5. 3 times 3 is 9. 3 times 7 is 21. And then we get 5, but it's a negative because of this guy, square roots of 21. And then 7 times 7 is 49. Okay, well let's look here. Before we go any further, I'm going to combine some like terms, which are these guys. So we have 1 minus 5. So I get 4 square roots of 21, which is prime. Can't do anything with it. But if you guys can see here, I have a perfect square here. So this actually goes down to 15 because 3 times 5 is 15. Well, I have a perfect square here too. When I pull it out, I get negative 7. Now, what's 15 minus 7? Well, 15 minus 7 is just 8. So now I have simplified this to this. Just have to make sure you're simplifying what you can. So, I like the boxes. Boxes keep track of everything for me because I will completely lose my mind if I don't have a box. So when we're looking at, dividing. Now here is, we're getting into a little bit harder. I'll refresh your memory on some dividing here. Where we have w to the 8th, x to the 3rd over 16. Well, we're going to look at it as you can take the square root of the top and you can take the square root of the bottom separately. Just leave them in the fraction when you're done. The square root of 16 is 4. The square root of w to the 8th is w to the 4th. Right here, it's not an even number yet. But when we make it an even number, we're left with an x square root of x. So, that's basic division. But now we're going to be asked to rationalize our denominator. Rationalizing the denominator means you're not allowed to have a radical in the denominator at all. That's just not allowed in math. So if I'm given 2 square roots of 11, and I need to rationalize this denominator. Basically, I need to get rid of that radical. So I have to multiply it by something that will get rid of the radical. And I need to multiply it by, basically I'm going to be multiplying it by itself. But I have to do both the top and the bottom. You multiply the top and the bottom by the square root of 11, and then you multiply straight across, and I'll show you what happens. So if we multiply straight across, we get 2 square roots of 11, and then 11 times 11 is 121. Take the square root of 121, you're left with 2 square roots of 11 over 11. That is now rationalized because it's not rational to have the square root on the bottom because that's an irrational number when it's prime. We need a rational number. So this is how we rationalize a denominator. We're going to multiply it by whatever is on the bottom underneath the square root because it gets rid of it. Because we have to rationalize. So here, let's look at something like this though, where we have 9y over square root of y to the 5th. Before we rationalize this, pull out what we can. So we're looking at this guy, and when I pull this out, it's now y to the 4th and y. So pulling that out, we're actually going to get 9y over y squared times y. Well, we only now have one radical in the bottom. So we're just going to multiply whatever radical we need to get rid of. So we need to get rid of this square root of y. So multiply the top and the bottom by the square root of y. When we do that, what we're going to get is 9y square roots of y over y squared square root of y squared. Well, what's the square root of y squared? The square root of y squared is y. So when I pull that out, I'm kind of left with something that looks like this. Y squared times y. And when we multiply that together, it's actually 2 plus 1 because you're just adding the exponents. So on the top, we're still left with 9y square root of y over y to the third. But then, we're still going, guys. It's this constant thing. But we have a y on top and a y cubed on the bottom. And when we're dividing, we subtract when we have something in common. So our actual answer is 9 square roots of y squared, because the bigger number is on the bottom. So now we have rationalized the denominator and simplified it as far as we can, and there is our answer. I know, it's insane, right? It's a lot of work, but you have to rationalize your denominator. So let's move on to something. Oh my gosh, I just like touched the marker. Let's move on to something like this. So if you're given square root of 2 over the square root of 7 minus the square root of 2. Well, to rationalize this denominator, we actually have to do it by the opposite of this. So instead of multiplying by the square root of 7 minus the square root of 2, what we actually multiply by is the square root of 7 plus the square root of 2 on both sides, top and bottom. Because that will get rid of it. And I'll show you how it gets rid of it. Because I'll use my little box method to get rid of it. This is how it works. It's a tiny little box. So the square root of 7 minus the square root of 2, square root of 7 plus the square root of 2. So we're getting here 7 times 7 is the square root of 49. 2 times 7 is the square root of 14. 7 times negative 2 is the negative square root of 14. And 2 times 2 is negative square roots of 4. This is why we have to do it by the opposite. Because if we don't, we're going to be left with a radical in the bottom. Our whole goal is to rationalize this to get rid of that radical. And right here we have a negative 14 and a positive 14. So now they're gone. Well, the square root of 49 is 7. And the square root of 4 is 2. So now on the bottom, we have 7 minus 2. Well, 7 minus 2 is 5. And now we're just going to multiply this through. So, distribute. I get the square root of 14 plus the square root of 4. And the square root of 4 is 2. And so you write it as the square root of 14 plus 2. And now we have rationalized that denominator. We have to do it by the opposite sign, because if we don't, then we have some issues and you didn't get rid of the radical. Okay. So let's look at something that's kind of more complicated, right? And you might need to use multiple boxes, which I love using boxes. So if I'm given square root of 3, 4 square roots of 3 plus 3 square roots of 2 over 5 square roots of 3 minus 6 square roots of 2. Okay, so if we're given that, we need to make sure we're multiplying this by the opposite of it, which is 5 square roots of 3 plus 6 square roots of 2. Make sure you multiply the top by the same thing. Okay. And we can do the bottom without a box, because I know that the middles are going to cancel out. So let's do the bottom without the box. 5 times 5 is 25. 3 times 3 is 9. 6 times 6 is negative 36. And 2 times 2 is 4. Because you know the middles cancel out when you're using the opposite, right? So I know that much. Well, 9, the square root of 9 is 3. So now it's 25 times 3. Square root of 4 is 2 minus 36 square root of, or times 2